All right, so let's look at our first method for solving systems of equations, and that's by graphing. And this is a method that works very well when it works and works terribly when it doesn't. And when I think it works best is when we have our equations in a real easy to graph form, like specifically y equals and then everything else mx plus b over on the other side. Partly because I can pop that in the calculator, and we'll do that in just a minute. But if I were to graph both of these lines, right, what we're doing is we're finding a pair of numbers that will work in each equation, or let's deal with the first one first. Y equals 2x minus 3. I put a 0 in there for x, and 2 times 0 minus 3 will give us negative 3. So 0, negative 3 is on that line. If I put a 1 in there, 2 times 1 minus 3 is negative 1, so the point 1 common negative 1 is on that line. If I put a 2 in there, 2 times 2 is 4, minus 3 gives us 1. And if you remember anything from our chapter on lines, these are going to be in a straight line. We have a slope of 2, right? Slope of 2, so we're going to go up 2 over 1, up 2 over 1, etc. And that'll give us a bunch of points on the line, and then we can just draw the line through those, and we know that it keeps going infinitely in both directions. Then we look at the other one, 12 minus x. That's going to start with a y-coordinate of 12, 2, 4, 6, 8, 10, 12. And it's got a slope of negative 1, so it's going to decrease by 1 every time we go over 1. So we've got a line that goes through those points. And the one line, or the one point that is on both of these lines, that's where the lines intersect, and that's the solution to our system. And that happens to be over 1, 2, 3, 4, 5 here. So x coordinate of 5, and a y coordinate of up 1, 2, 3, 4, 5, 6, 7 looks like. So the point 5, 7, or the pair of numbers 5, 7, will work in both equations. And we can see that it will. 2 times 5 minus 3 is 7, and 12 minus 5 is also 7. So it works in both of them. Now, if we wanted to do that in the calculator, it would be easy. We would go to our y equals screen, and we type in y equals 2x minus 3, and also y equals 12 minus x. Then we go to our graph screen, still in a window from an application. So I'll zoom 6 to get back to our regular screen. And any problem that I'm going to give you or ask you to solve by graphing, you want to be on this home screen here. And then these keystrokes I've covered many times in class. Second, trace, 5, enter, enter, enter. And since there's only one point of intersection, that's the one it'll find, and it give us the coordinates right down there, 5, 7. Okay, so you're welcome to use technology to solve these. You're welcome to do them out by hand. Choice is yours. Do one more real quickly. Put this one here, y equals 5 minus 2x. So I would put 5 minus 2x in for y1, and then x plus 11 in for y2. Go to the graph screen. You can see the intersection point right there. Second, calc 5, enter, enter, enter. And negative 2 comma 9. And I'm not even going to bother putting that one on paper because you've already got a picture of it right there and we know where they intersect. And that's it for solving by graphing. It's, as I said, it's good when it works, when these numbers are nice, or when you can deal with negative or nasty decimals. But it works best when you've got the lines in this form because they're easy to graph. And if I'm going to give you one on a test, that's how it's going to be later.